So this question reads, for square matrices A and B, prove or disprove the following. Let's start with A. A says the determinant of the transpose of A is equal to the determinant of A. There's a few ways we can go about this, but let's just make some random example up, and we're going to try to see if it works. So we have this matrix 1, 2, 3, 0, 2, 1, 3, 1, 2. I made this up. It doesn't have to be anything specific. So we're going to take the determinant of this matrix, the transpose of it, so we're going to do this, and we're going to see if it is equal to the determinant of the same matrix. So the first thing we're going to do is we are going to take the transpose of the matrix. To do that, we just switch the columns with the rows of columns. So here we have row 1, and that becomes column 1. So we have 1, 2, 3. Now row 2 is column 2, 0, 2, 1. Number 3 is number 3, so 3, 1, 2, just like this. And we are going to take the determinant of this and see if it is equal to the determinant of our original matrix 1, 2, 3, 0, 2, 1, 3, 1, 2. So I always like using Zara's rule here. For the first one, we're going to have our matrix and we're just going to expand it. So we're going to rewrite our first two columns to the right. So 1, 0, 2, 2, 3, 1. And at the same time, we're going to be finding the determinant of this. So 1, 2, 3, 1, 2. 0, 2, 1, 0, 2, 3, 1, 2, 3, 1. Let's draw our diagonal lines. So here we have 3 times 3 times 2. 3 times 3 is 9, times 2 is 18. 1 times 1 times 1 is 1, so plus 1. 2 times 2 times 0 is 0, so 18 plus 1 is equal to 19. And then here we have this diagonal. So here we have 2 times 2 times 1, which is 4. The next one, 0 times 1 times 3 is 0. 3 times 2 times 1 is 6. We add these together is 10. Bottom minus top. 10 minus 19 is equal to negative 9. And let's see if that is equal to the determinant of this matrix. So we do the same thing. We draw our diagonal lines. 3 times 2 times 3. 9 times 2 is 18. 1 times 1 times 1 is 1. 2 times 0 times 2 is 0, so we have 19 up here. 1 times 2 times 2 is 2. 2 times 1 times 3 is 6. Sorry, 1 times 2 times 2 is 4, not 2. So 4 plus 6 is equal to 10. 10 minus 19 is equal to negative 9. Negative 9 is equal to negative 9. So this is true. For number B, for letter B, we are giving the determinant of A plus B is equal to the determinant of A plus the determinant of B. Let's go ahead and make some random matrices. Here, let's just do a 2 by 2 matrix because it says square matrices. Let's do 1, 0, 2, 1. And B is equal to 3, 4, 2, 1. Now we're asked to see if the determinant of A plus B is equal to the determinant of A plus the determinant of B. Let's just find the determinant of A first. To do that, we multiply these two minus these two. So 1 times 1 minus 2 times 0 is equal to 1. So the determinant of A is equal to 1. For here, we have 3 times 1 is just 3, minus 8, which is minus 5. The determinant of B is equal to minus 5. Now, let's add A and B together and see if we can find the determinant of that. If you remember how to do that, all we do is we take each corresponding number and we just add them together. So here, top left plus top left. 3 plus 1 is 4. Here, 0 plus 4 is 4. 2 plus 2 is 4. 1 plus 1 is 2. Now let's go ahead and find the determinant of this. 4 times 2 is 8. 8 minus 4 times 4, which is 16, is equal to negative 8. So here we have minus 5 plus 1, which is negative 4. Negative 8 does not equal negative 4. So this is not true. If it doesn't work for one case, it's not going to be true. Maybe it works for the exception, but because we've disproven it once, it's disproven. So lastly, we're asked to see if the inverse of A, and we're going to take the inverse of that answer is equal to A. And let's just do a 2 by 2 matrix because those are a lot easier. We have 3, 4, 2, 1. This is A. Now, the inverse of A is going to be equal to 1 over the determinant times D minus B minus C A. So hopefully you know that equation. If not, well, you should look at past videos, make sure you get that. So we're going to take the determinant of it first, so that's 3 times 1 minus 4 times 2, which is 3 minus 8, which is negative 5. So we're going to do 1 over negative 5 times D, so we're going to switch this, so that's 1, negative 4, negative 2, and 3, because we're pretending this is A, B, C, D. Okay, so let's take the answer to that, and we get 1 times 1 over negative 5 is negative 1 over 5. Negative 4 times 1 over negative 5 is 4/5. Here we have 2/5 and negative 3 out of 5. So I just rewrote that right here, and we are going to find the inverse of this answer now. So remember to do that. We do 1 over the determinant times D minus B minus C A. The determinant of this is going to be negative 1/5 times negative 3 out of 5 is equal to 3 out of 25. And we're going to do minus 2 out of 5 times 4 out of 5, so 4 times 2 is 8. 5 times 5 is 25. And then here we have 3 minus 8, which is negative 5 out of 25, which is equal to negative 1 out of 5. So now we want 1 over the determinant. 1 over this answer is going to be equal to, oh, that's wrong, is going to be equal to negative 5, and we're going to multiply that by D minus B, so A, B, C, D. D is minus 3 out of 5. Negative B, so negative 4 out of 5. Negative C, negative 2 out of 5. And then negative 1 out of 5. Let's just write our answer up here. So we have negative 5 times negative 3 out of 5, which is equal to 3. So that's good. Then we do negative 5 times negative 4 out of 5, which is 4. Then we have negative 5 times negative 2 out of 5, which is equal to 2. And lastly, we have negative 5 times negative 1 out of 5, which is 1. So yeah, when we take the inverse of an inverse, we get the original matrix back. Now sometimes it's not always enough to just show one example to prove something. You should also know the theory behind it, but this was just to like go over some examples to prove it visually.